So looking at this problem, you can see that you are given two replications per cell, right? You are given two replications per cell. So it's possible that we may decide not to give you what the replications per cell, and you are given a problem in this format. Let me I'm coming now. I want to show you what I'm talking about. Um, suppose we're given this problem in this format. I don't know what's happening. Don't worry about the black. Oh, sorry. What's happening now? Let's check this table now. The second table. Don't worry about the weighting. The second table now, you are given the totals for each treatment combinations and their standard deviations. You are given the oh, this means the formatting here. This value shifted. Oh, but it was fine. Let me do like this. It's fine. What I can do is method of copy, creating a column here. Suppose we have this information. It's fine. I'm trying to make life easy now. Copy. Paste. Thank you. This is the standard deviation. You see the problem? So I'm saying, suppose you are not given this information. Suppose that information is not given. How will you find the standard error? Or the sum of, sorry, not the standard error. How will you find the suppose the problem is given like that, but you are told that you have two replications per cell. Two replications per cell. Finding finding the factors is not a problem because you'll use what? You'll use that total, right? But you're not given the original values. So it's not possible for you to find what? It is not possible for you to find it's not possible for you to find SSTO, because for you to find SSTO, you need the actual values, right? You must first square the actual values minus the sum of all the observations. That one is not a problem. You can get it from this one. But since you are not given the actual values, now how will you find SSE? That's my question. How do we find SSE given this information?
Sir,
Yes?
are we not going to add the variances from each treatment combination square?
Yes.
I think that's how we find our SSE. We're going to take each and every a standard deviation, we square it and add all of them.
Is the formula correct, Mr. Manga?
Replication is already true, sir, if I recall from what we did before, unless things changed. So
No,
2
it's
minus
same.
1 is 1. So that's
Yes.
what I'm saying. So
So it means the formula to deal with this problem is r minus 1. You know these things from chapter 2. Sum of summation in brackets of SD squared. Isn't it, Mrs. Mark?
yes, sir, yes, sir.
So that is the formula that we'll be using, right? It's r minus 1 in brackets the sum of the SD squared. That formula will help you to find what? It will help you to find SSE. I'm saying this because I gave you an assignment and there was mixed emotions. Students now, they were accusing me of bringing something that I didn't teach you. But when I take you back to first semester, you covered that part on the first semester. So some of these things you just need to recall what we have done before. So these questions can come in different formats. So this is the first thing that you have to understand. So you see, the original question is what? The original question does not have what? These standard deviations. But it's possible that I can give you the question in the form of standard deviations without the original values. So let's check the second one before you do some calculations. Tell me the information that you are able to get from the statement and we'll do the calculations. What are you seeing, guys, from the statement? Anyone? I spoke about this issue of levels last week. For those who attended my class last week, I gave several examples concerning the levels of each factor. If you attended my class, you must be able to know what is happening there.
Two levels each.
2 levels each. Okay. So how many factors do we have? We have to start from there. How many factors do we have?
3.
Let's attach the signs. Let's attach the signs. What can you get from the first 3 columns? What are you having there? From the first 3 columns, you must be able to tell me something.
A is high, then time is
No,
low.
give me the signs first.
Okay, it's positive.
Positive. You will explain. Chris, explain why you are saying this is a positive. I'm getting this information from Chris. He's saying the first one is positive. Chris who's saying this, not me.
Yeah, it's positive, and then the next one is
Just go down.
negative.
Yes.
Negative, positive, positive.
Yes.
negative, negative, negative again. And the last one is positive.
If you have 4 negatives, it means you must also have 4 positives. In each and every column, if you have four positives, even the negatives, there must be 4. Can you please confirm that? Are we winning? Are we having 4 positives and 4 negatives?
Yes.
Anyone who's still lost? Anyone lost? Guys, talk to me. Do you understand how Mr. Chris managed to get these signs? Do you understand, guys? Guys, you are quiet.
Yes,
Do you understand how he managed to get the signs? So it's fine if you understand novella. Give me the signs for the second column.
negative, the first one.
Negative.
Negative,
Yes.
positive.
Positive,
Negative,
right? Negative.
negative,
Negative.
positive,
Positive.
positive,
Positive.
positive.
How many positives do we have? If we have 4 positives, we must also have 4 negatives. So when you deal with the main effect, the rule is like that: 4 positives and 4 negatives. I think it also applies to so the last one. Now there's no need for us to waste time because now I assume you understand what is happening. Negative, negative, positive, negative. So from the question, we are told that we are given the total, right? This is the total. It's not, this is the total now. Total of whatever is given here. So now, let's attach the treatment combinations. Based on this, the signs now we have the signs. Let's attach, let's now write the treatment combinations. Based on the signs now will guide you that the first row is going to give you what? The first row, the second row, and so forth. There is a note at the bottom of the table. There is a note there. That note is very, very important because you are told that note that these runs are given in actual random order. Are given in actual random order. They are random, not in a standard order. You know the standard order of writing this. So now, give me the treatment combinations now. Let me create a column. Give me the treatment combinations. Treatment combinations.
First row is A.
This is saying the first row is A. Another person, let's get a different person. Small letter A, right? Not capital letter.
The second row is small letter C.
C. Can you please explain CH why you are seeing a small letter C so that those who are lost can follow? CH.
Because on the temperature is set low and time is set low, but the concentration is set high, so it's C.
Thank you very much. Thank you very much, CH. This one is representing B. The last one is representing C. So let's go. Not Malulek, another different person?
ABC.
ABC. What is this thing? ABC, let's go. You must be jealous, guys, if you leave the class without saying anything. Let's go.
AC. AC.
AC. Yes, let's go.
1.
1. Yes.
B.
A.
B.
B.
BC.
BC.
AC.
AB, right?
AB. Yes.
Yes. So you see, that is why the statement was saying, this statement here, this statement is very, very important. Note that these runs are given in actual random order, not a standard order. So if you have to apply the Yates algorithm, let's focus on the question. Which method are we use to solve this problem? We are told that we have to use what? We have to use the Yates algorithm and estimate the main effects, the 2 and the 3 factor interaction. Using what? The Yates method. What is the secret of the Yates method? Order matters. So you cannot solve the problem with that using this order. You must first write them in a standard order. So the Yates algorithm or the Yates method, the correct order is this one, the one that I'm about to write now here. Yes, the correct order. The first one is supposed to be neutral, followed by A, B. This is the recognized order. A, C, B, C, A, B, C. That is the only recognized order. So now you see your table now. If you check your table, it's not in this order, right? So rule number 1, you must first rearrange your treatment combinations in this order. Whenever you move them with what? With their totals. Yes.
The order, is it not A, B, C, then A,
No.
B?
No. The way I wrote it is A, neutral A, because now you can have an interaction between A and B. You say AB before you move to C. But if you are using the other method of signs, there is no need for you to order them, right? You can calculate them the way they are. There's no need for you to do the reordering and all those things, because the thing does not matter. That is the order, Chris. I think you are worried about this one, right, Chris? For the Yates algorithm, this is the order, because now you have neutral, right, Chris? You have A, you have B. It means you can find the interaction, right? That's why now multiply the two before you move. If you can check this one, now because you have C, you can multiply A and C, B and C. From there, the last one will be A, B, C. Any question, guys? We have the question, and I suggest we use the Yates algorithm. Columns I will create. How many columns are we going to create? So the order, first thing when you're dealing with the Yates algorithm, you put your treatment levels in this order first, before you divide the treatment combinations into pairs. Rule number one, make sure that your levels are in what? Are in your treatment combinations are in what? In a standard order, which is the one that I indicated there. And what else? After that, the problem is no longer an issue. So can someone remind us about the procedure for dealing with the Yates algorithm? What are the rules?
Sir,
Yes.
we first have to divide the treatment combinations into pairs. It means we're going to divide them 2 by 2.
After ordering them, right?
After ordering them. Then we're going to
Okay, you divide them into pairs.
yes. So and also we're going to add the observation from each pair for the first half and subtract observation from each pair of the last half.
Thank you very much. So that is and then how many columns are you going to create, Mr. Smang?
Since we're having 3 factors, we're going to create 3 columns.
Yes. So the rule says when you want to find the information for the first column, you use the totals, right? When you want to find the information for the second column, you use the information from the first column. When you want to find the information for the third column, you use the information of the second column. So please get that one right. So I prepared 2 questions for you here. The other one is this one, where I was talking about the what? I'm not sure if I'll be able to remove this color. So we have 2 questions, guys. Which one do you want us to solve? This one, I'm not specific. So in a case where I'm not specific, like this question, you see, I'm not specific which method you can use. I'm just saying prepare an ANOVA table and determine which factors are important in explaining the yield. I'm not specific which method to use. But when we check the second one, I'm specific that please, I want you to use the Yates method. So it means for this one, strictly Yates method. But for the first one, even if you use Yates method, because at the end of the day, we'll get same results. So for this one, you can use the where you use the signs and where you use what? The Yates algorithm. So which one do you want us to do, guys, between 1 and 2? Or maybe I start with this one because it doesn't have some decimals. Hey, the other one, you see this? Did you see the values? Some decimals here. So can we solve the first one using which method do you prefer? Let's solve the first one. Now it's 2 to the power 3. Which method do you prefer?
Both.
Mara, we have to use one, miss.
Okay, the algorithm.
It's fine. Let's go. He's saying we use. Yes, it's fine. Let's use the Yates algorithm. Are we happy with the order? Are we happy with the order of the thing?
No.
Are we happy with the order of the treatment combinations?
No.
What is the problem? It's here, right? There's a problem somewhere here, isn't it, guys? Because now we are saying we have to use the Yates algorithm. So this one was supposed to be here, right? Are we happy now? So now we can create those columns. Right, one. We need another column. Right, two. I was told that we need 3 columns. Column 1, 2, 3. Call 1, call 2, call 3. Give me the values now. You divide this into pairs. So you'll have this pair. And this one again will be a pair. Let me do it like this. You'll have that pair. And let's go, guys. I assume you're doing some calculations. I want to write the values here. These are the pairs. I'm just guys, are you still there?
Yes, sir. 335.
You're saying what is happening? 3, 4.
335.
335.
335,
Yes.
sir.
The first one is wrong.
It's correct now.
Eight to nine.
Sorry?
329.
Yes.
316. 313.
Let's go, guys. Let's go.
Negative 31.
Negative 31.
Negative
Okay.
3.
Negative 3.
6.
6.
Yes. Negative 27.
Negative 37 or 27.
27.
It's correct, right? The one what I wrote there. So let's go. Let's continue with the problem. So now, because you want to deal with column 2 now, you will use the information from column 1. Yeah, give me the values. Give me the values. Don't worry about my colors. Give me the values.
664.
Yes.
664.
Six two nine.
629.
Minus 34.
-3.
Okay.
-21.
Minus 21.
Yes. -9. -3.
Okay.
So it's -6, not -9.
I'm waiting.
Minus 34.
Minus. How are you getting minus, Chris?
My, no, it's not 34. Minus 28.
Why minus
No,
28?
it's 28.
Oh, yeah. So it's 28.
-3.
Let's do the last column, guys. Let's go. Let's go. You do the same thing. You know that you put them into pairs to avoid, you know how to do it. It's not like even when you're writing, you must bring these colors. I'm just
So,
trying so that
1,
you
2.
follow, guys. Yes.
sir,
Chris, you have a question? Yes.
so when we have 3 treatments, we are going to have 3 columns.
Yes. No, why not treatment? When you have 3 factors, treatment is
Yeah, 3
something else.
factors. Okay.
Yes. That's why I said when you have 3, it's even if you recall what Malek said, CH, he said you'll be guided by the number of factors that you have. If you have 3 factors, it means you are going to have 3 columns. If you have 2 factors, like the one that we did in last week, I want to have two columns. 2 factors, 2 columns. 3 factors, 3 columns. 10 factors, 10 columns. Let's go. We're saying what is this one?
1, 1, 2, 9, 3.
1, 1, 2, 9, 3.
9, 3.
Sorry? My sister,
-5, 5.
I lost negative 5, 5.
Yes.
How? Oh, yeah, that is negative. Yes, negative 9, right? Negative
Yes.
9.
Sir,
Yes.
someone was requesting if you can extend the link. They are trying to join the class, but it's not there.
The link.
-5.
Yeah, the link.
Yeah. Continue solving. Let me try. I don't even know where to go. Let me see. The issue is the time, right?
Yes.
And if I can live here, hey, coming back is it's not easy. I don't know what's happening now. Yeah, continue with the problem. Solve the problem while I'm trying to continue with the problem. Let me change the time. What is today's date? Today is what? It's October, right?
14.
14. Okay. This can be true. Our left with because next week we'll be doing the tutorials. We'll need only one. We need only one an extra class where we'll be doing the tutorials based on chapter. Based on that the two chapters that we covered. So next week's only the tutorials from there were done. That's where we're going to conclude everything on Tuesday. Otherwise, but before the end of I did Chris. Can I continue with the solutions? I'll tell them to try now. I managed to do that. Let's go, guys.
Negative 35.
Negative 35.
13.
18.
Yes, 13. Negative 3. Negative
Negative
61.
60.
How did you get this negative 3, Chris? If I may ask.
It's 3. I got
It's
3.
3. Chris, what is happening with the signs?
Sorry, sir.
Negative 61.
It's just with this part here, with this part, even if you made a mistake with the sign, it won't affect the if it's the last column. It won't, but except the first one.
Okay.
Even if the answer here is supposed to be negative, it's supposed to be 55 and not negative. Remember, I'm still going to square these values, so they will change to positives when you square them. So even if you made a mistake of
Okay.
sign, as long as on the last column, you are still safe to get the ANOVA table right, but you'll be penalized for writing the wrong value there. But since these values you are going to square them, they will change to
It's negative 61, not 51.
it's what?
61.
6.
Yes, negative 61.
Yes. So those are the values, guys.
And the one left is
Yes.
it's negative 5.
This one.
Yes.
Do you agree with the values, guys? So, let's find the contrast. Let's find the contrast, or let's find, these are the contrast, right? These are the contrast. Let's find SSA, SSB, and up to the end, the last one. Someone's mic is on, guys. Please. SSA is what?
Sir? Sir?
I'm listening.
Why don't you go directly to the ANOVA
What do you
after
mean?
year? I say if after year I just go directly to the ANOVA. Then I put those videos.
No, it's not a problem. As long as the values are correct.
Okay, thank you.
SSA, how do you find SSA?
Negative 55 over 4 times 2.
Why 4, Chris?
Oh, 8 times 2, not 4.
8 times 2. So the first one will be negative 55 squared divided by 8 multiplied by 2. Find the answer. What is the answer for this one? You do the same thing for even for the other ones. What is the answer?
189.06.
What?
189.
189.
0.06.
06. Let's find for B. I'm no longer going to write the things. No? B is what? Guys, you're taking time. Why? 5.3.
5.06.
And then C. Can I get a different person, please? Seems like the leader here is the only one who's focusing. What is happening with the other guys?
So it's 76.56.
76.56.
Yeah.
And what else? So finding this one's, oh, this value is for C or is for AB?
It's for C.
Oh, okay. For AB. So people are not here because they're celebrating that they're qualifying or what? Why are they not here?
1.
Is it because they're
One-
qualifying?
1.56.
1.56.
25.
So the ANOVA table, you create it, right? You'll construct it We're almost done. Almost done, guys. We have 4 in the bag. We're left with 3. This one is what? AC, BC, ABC. So guys, people are still celebrating that they're qualifying by surprise. Let's go.
10.56.
10.
Then the BC. Because my question is, how many minutes do we need to solve this type of a problem?
0.56.
Be realistic, because 0.56.
232.56.
232.56. I'm told that this is the answers. I didn't confirm them, but my leaders. Check SSTO. You know how to find STO. The actual values here. Values here, you square these values minus the total. Yes, the total here. This 1293 divided 16. I think the values are 16 because we have 2 replications per se. So there's 16. One. Whatever I'm getting, I can test, or I can try to validate it by now using the other formula. So let's check it. What are you getting when you square r minus 1? It will be 1. When you square them and add them, what are you having?
47.53.
47.53.
Yes.
Our formula is correct, or it needs final beating. We have to check if this formula is fine. Can be used here.
SSTO is 563.45.
R minus 1, R is the same, but in a case where R is different, case where in some problem, you know what happened at chapter 2. What is your SSTO?
563.45.
536, right?
563.
563, sorry. You have to confirm the values, guys. I don't want a situation where at the end you say the value. If the value is wrong. Is Manga still here? Mrs. Mang?
Sir, I'm here.
You're quiet. What's happening?
Nothing,
Malek, I
sir.
understand this. Malek, I understand the network is troubling him there. Even Ramulifo, I can see that the network is not strong at all.
Sir,
Yes.
my network is working very well. I'm just observing and giving others a chance.
Thank you very much. Thank you very much. As long as you follow. What are we having, guys? Guys,
$47.53.
47.53, right? So it means you have to be strategic when you're given this type of problem. If you are given only this information, if you are not given this part here, sorry, let me use this color. If
Sir.
you're not given that part, guys, yes.
Oh, those two formulas are different for SSE. Okay. I wanted to know the difference between the
No,
two.
Chris, why I'm emphasizing this? Yes. Now the challenge is one, Chris. Suppose you are given the information like that. You don't have what? You don't have the exact values, right? If you don't have the exact values, I want to close this. Yeah. Let's say the problem is like this, Christoph. Can you see it? You are only given the standard deviations. You're only given this part and the standard deviations. Remember, it means it's not possible for you to find what? To find SSTO. Am I wrong, Chris? Can you see it?
Yeah.
You cannot find SSTO only given if you are given SD and total. Because for you to find SSTO, you need what? You need the exact values. You need the exact values for you to find SSTO. But in this case, you are not given. And it's not always the case that, like for my question here, for this one, for example, for this one, you see, what are you given? For this second question, you are not given the what? The exact values. You are only totals. But now I helped you with what? I helped you with the SE. You can use this MSE to get what? The SSE. As long as you know the formula, you don't need SSTO to get that information. So even for this one, if you are not given the exact values, there is no way that you can find SSTO. So you must know the alternative formula that can be used, which is in this case will be this formula here. Because you are told that how many replications do we have? We have 2. You are given the standard deviations. If you are given the variances, if you are given the sample variances, you just add them. You don't have to square them. Suppose here this was the variance. If you are told that these are the sample variances, sample variance, how do you find SSE? If it's the variance, you don't have to square them, right? You just add the values and multiply them by r minus 1. In our case, r minus 1 is 1. Any question, guys? Any question based? So constructing an ANOVA table, you can do that one. So please, you answer the question. It says, determine which factors are important in explaining the yield. So you just indicate when you conclude. You don't have to conclude one by one. You list them. If factor A is significant, you say factor A, factor C, factors A for the main effects, A and C. For the interactions, you indicate that A and B, A, B, C, these are the factors that are important in explaining the yield. You don't have to say hypothesis testing for A. You just list the factors, like what we did last week. Just say for main effects, this factor and this are important. Interactions, this one and this one are important, and so forth. Yes?
So they're important when they are significant or insignificant.
What do you think, Mrs. Manga? Sorry to take you to reverse the question. What do you think, Ms. Manga?
Truly speaking, on the conclusion, I have no idea.
But what do you think? So, guess. Can you please guess?
I think when there
I
is
think my brother
no
is trying to help you.
interaction, when there is no interaction, when there is no, when they are
Well, no, remember, no, the
when they are
the main effects.
insignificant.
My brother, can you help? Can you help us? CH? We cannot hear you, CH. Anyone who can answer Mr. Manga's question? CH, we cannot hear you. Your network is bad. Anyone
So
who
is
can
it?
help us to get Tuto?
I think it's significant.
Yes. If they're significant, it means that they are able to help us to predict what? To explain why, right? We're able to explain why if they're significant. So the ones which are significant are the ones which are important. Even last week when we were dealing with that question, I asked you, tell me which factors are significantly different from 0. They're only different from 0 provided what? Provided as significant. Now I can take questions. The other one, you go and solve it, guys. The other question, you'll go and solve it yourself. Can I get questions?
Please send the document.
I'm done with my part. So constructing over T. So now, how is this section? Is it that difficult? So Chris, remember, you said we have to use also know how to use the other one, the one where you use the signs, the one where you use the signs. So this one, our main focus was on the Yates algorithm. So try the other one now using the signs, or you solve the same problem now using the signs. You must reach the same conclusion. You must reach this conclusion. If you and when you use Yates algorithm, you must the same conclusion. So this contrast must get the same thing. You can even try A. Let's just check if we're going to get the same thing. For A, let me create a column here. There we'll call it a day. Let's check if use the size. Are we going to 55? Create one column here. Negative. Negative and positive. Use signs, guys. Use the signs and the totals. You start from the bottom. 143 minus 170 plus 161 minus 155 plus 163 minus 166 plus 153 minus 183. What are you getting, guys? Let's find the sum of A using the signs. Are we getting negative 55?
Yes.
What are you getting, guys? Leaders, you are quiet. I'm worried now.
Sir,
Yes.
isn't it positive on the second row?
This one.
Yeah.
So I'm getting negative
Positive.
35.
It's just a small positive. It's positive. Let me increase the font. It's positive.
I'm getting negative 35, sir.
Someone who said is getting 55. Check. Negative 35. What about the head? Someone is getting 55. Getting negative 55 at the time. Is uh, you are right. Getting the same value minus 55. Please write on